comparing more than two groups. So just like how we went through the nonparametric test, this one is the equivalent of the ANOVA. So it's when we have three groups, say, or more that we're comparing. And what we would use is the Kruskal-Wallis test, and it evaluates whether the medians differ significantly between the multiple groups. It requires random samples, that the three or more groups are independent of each other, and it does allow the dependent variable to be either ordinal, interval, or ratio level data. So let's say a researcher wanted to study the use of 3 different distraction techniques to decrease anxiety. So he randomly assigned patients to get one of the 3 techniques and then had them rate their anxiety levels afterwards. So if you had just seen this, you would probably be thinking ANOVA at this point. All right, so we need to write our null and research hypotheses. Our null hypothesis is that there will be no difference in anxiety between the 3 groups. And our research hypothesis, remember, just like with the ANOVA, is that at least one of the groups of patients will have a different level of anxiety than the other groups. And I'm writing all these hypotheses as non-directional, so I'm not telling you which group I think will be higher or lower. And that's because I just don't know these topics that I'm presenting. So we're just seeing, is there a difference? We don't really know what to expect. We're going to choose our level of significance and determine our test. So we would pick 0.05 just because we don't really have a reason to make it smaller or larger. We would initially probably think of the ANOVA, but if our assumptions weren't met, if our dependent variable wasn't interval ratio level, it was ordinal level, then we would switch to the Kruskal-Wallis test. And we would run the test in SPSS and obtain our test statistic and our p-value. And this is what the output of a Kruskal-Wallis test looks like. It gives you your 3 or however many groups you have. It tells you kind of descriptives about it. So it looks like we had 5 people that were in the first group that received the first distraction technique, 8 people that received the second, and 9 people that received the third. So we had 22 people total. It looks like group 3 had the lowest anxiety ratings and group 1 had the highest, but we don't know if any of these are statistically significant. So what we do next is look at the next table, which gives us our test statistic. And we call our test statistic an H for the Kruskal-Wallis test, and then our degrees of freedom is listed in that table. So remember, that's always the number of groups minus 1. So in this example, we're comparing 3 groups. So 3 minus 1 is 2. So we would put H, and then our degrees of freedom, 2, equals 2.317. And our p-value is 0.314. So we're going to make a decision based on that p-value. And since our calculated p-value is greater than our level of significance, we're going to decide to fail to reject the null hypothesis. So remember, our null hypothesis was that there would be no difference in anxiety between the 3 groups. So if we're failing to reject it, we're not throwing it out, then we're going to say, okay, we might have seen what looked like difference, but there was nothing statistically significant different between the 3 groups. And we'll make our conclusion. There's no statistically significant difference in anxiety between the different distraction techniques, and then we'll report our data.